Find the ratio, length AOP to length AOC. Label D and E. Let O be the center point of the circle. Join line OD. It implies that line OA equals line OD, which equals to R, the radius of the semicircle. Consider a square EOCD. Use Pythagoras' theorem. The square of line OD equals the square of R, which equals the sum of the square of line OC and the square of line CD. Since area of the square EOCD equals the square of line CD, which equals to 4, it follows that line CD equals the square root of 4, which equals 2 centimeters. The result is equals to line OC. Hence, the square of line OD equals the sum of the square of 2 and the square of 2, which equals 8. Take the square root of the equation. Also, join line OP, which equals to R, from triangle EOA. Use Pythagoras' theorem. The square of line AE equals the sum of the square of line OE and the square of line OA. Substitute values and we have that the square of line AE equals the sum of the square of 2 and the square of 2 times the square root of 2, which equals to 12. Take the square root of the equation. It follows that the length of line A equals the square root of 12, which equals 2 times the square root of 3. By trigonometric identity, cosine A equals line OA divided by line AE, which equals to 2 times the square root of 2, all divided by 2 times the square root of 3. The result is equals to the square root of 2 divided by 3. This implies that cosine A equals the square root of 2 divided by 3. We call it equation 1. From isosceles triangle AOP, cosine 180 degrees minus 2 times A equals negative cosine 2 times A, which equals to 1 minus 2 times the square of cosine A. Substitute value of equation 1 and simplify. We have that cosine 180 degrees minus 2 times A equals negative 1 divided by 3. We call it equation 2. Use cosine rule in triangle AOP. The square of line AP equals 2 times the product of the square of R and 1 minus cosine 180 degrees minus 2 times A, which equals 64 divided by 3. After simplification of substituted value. Take the square root of the equation. It implies that line AP equals the square root of 64 divided by 3, which equals 8 divided by the square root of 3. The final result equals 8 times the square root of 3, all divided by 3 in centimeters. But line AOC equals the sum of line OA and line OC, which equals the sum of 2 times the square root of 2 and 2 in centimeters. Therefore, the value of the required ratio, length AOP to the length AC, equals 1/3 of the product of 4 and the square root of 3 times the square root of 2 minus 1.